Something just survived in the cold vacuum of space, and it's alive. Not metal, not artificial. Alive. China's Tiangong space station, orbiting silently above Earth, has made a discovery no one expected, no one can fully explain. Bacteria found clinging to life in one of the most inhospitable environments known to humanity. How did it get there? Why is it still alive? And what does it mean for the rest of us? This isn't science fiction. This isn't a maybe, it's confirmed. A living organism, thriving or at least surviving where nothing should. And now, the world's leading space agencies are on high alert. Because if something can live up there, what else is out there? Could this be a mutated strain from Earth? A sign of alien contamination? Or the beginning of something much bigger than we've imagined? Tonight, we're breaking open a story that's unfolding above our heads. And it might change how we think about life not just in space, but on Earth too. This is the Daily Scope, and this is the discovery they didn't want you to panic about. Imagine the vacuum of space. Cold, silent, and utterly hostile to life. Now imagine scientists on the Tiangong space station finding not dust or debris, but living bacteria thriving in this environment. This discovery challenges everything we know about where life can survive. The fact that these tiny organisms have not just survived, but mutated inside one of the harshest environments known to humanity is nothing short of extraordinary. It forces us to rethink our assumptions about life's boundaries, making us ask, is space really as lifeless as we thought? This shocking revelation isn't just a scientific curiosity. It's a wake-up call for the entire space exploration community. The bacteria found belong to the hardy species Bacillus subtilis, known on Earth for surviving extreme conditions like heat, radiation, and drought. However, the strain aboard Tiangong isn't an ordinary one. It shows signs of mutation, something scientists have never seen before in space. This mutated microbe's ability to adapt and potentially evolve in orbit is both fascinating and frightening. It suggests that even the tiniest life forms can find ways to thrive beyond Earth's protective atmosphere, possibly unlocking secrets about life's resilience that could rewrite biology textbooks. One of the biggest mysteries is how these bacteria arrived on the station in the first place. Despite stringent sterilization protocols, bacteria can hitch a ride on cargo shipments, tools, or even astronaut suits. The idea that microscopic life accidentally traveled aboard a spacecraft and then adapted to space's harsh conditions adds an element of suspense to the story. It also highlights the challenges of keeping human missions truly sterile, especially as we plan to send humans further into the solar system. This accidental stowaway might be a simple contamination or the first hint of a much larger biological mystery. Space is a brutal laboratory. Microgravity, cosmic radiation, and fluctuating temperatures create a unique environment that influences genetic material in unpredictable ways. Scientists theorize that these extreme conditions accelerated the mutation rate of the Tiangong bacteria, causing rapid adaptation that wouldn't happen on Earth. This opens the door to a new understanding of evolution, one that can occur not over millennia, but in mere months or weeks in space. It's a chilling thought that life beyond Earth could be evolving at a pace and in ways we never anticipated. This discovery isn't just about bacteria. It's a warning for future space exploration. Planetary protection protocols aim to prevent Earth microbes from contaminating other worlds, and vice versa. If bacteria like these can survive and evolve in space, they might jeopardize missions to Mars, the Moon, or icy moons like Europa, risking contamination that could destroy fragile extraterrestrial ecosystems, or even cause false signs of life. Understanding these microbes and controlling their spread is crucial if humanity wants to explore the cosmos responsibly and safely. Although the discovery originated with China's Tiangong, it has sent ripples through the global space community. NASA, ESA, JAXA, and other agencies have quietly requested data and are reviewing their contamination safeguards. There is an unspoken urgency to learn from this discovery and prepare international protocols for microbial threats in orbit. Behind the scenes, there's a renewed space race atmosphere, not just to land on new worlds, but to control the invisible life forms already traveling with us. This development could reshape how space agencies collaborate and compete in the coming decades. The discovery of mutated bacteria aboard the Tiangong space station has done more than just surprise scientists. It has reignited one of the most ancient and controversial theories in all of cosmic science, the panspermia hypothesis. And once you understand what this theory really means, you'll never look at life on Earth the same way again. At its core, panspermia suggests something profoundly humbling: that life did not begin on Earth, not in its oceans, not in its volcanic vents, not even in its atmosphere. Instead, life may have arrived, carried here on the back of a comet, buried inside an asteroid, or tucked within the microscopic crevices of cosmic dust. It may have traveled through the freezing void of space for thousands or even millions of years, until, by pure chance, it landed here. And if that's true, then everything we know, every tree, every whale, every bird, every human emotion, every war, every invention, every heartbeat, began with a speck of life that didn't even originate on this planet. Now take that in. This isn't just a theory anymore, whispered in obscure scientific journals or sci-fi novels. The Tiangong bacteria, alive, mutated, adapting in space, may be living proof that life doesn't need Earth to survive, doesn't need oxygen, or a stable temperature, or even gravity. It just needs time, and the vastness of space. It offers time in abundance, infinite, ancient, and patient time. The implications are staggering, because if Earth bacteria can survive in space, then life, even at its most primitive level, is not fragile. It's not delicate. It's relentless. It means that life may not be rare in the universe at all. In fact, it might be everywhere, not just possible, inevitable. Maybe the cosmos itself is biologically fertile. Maybe life is a cosmic consequence, not a lucky accident. And Earth might just be one garden in a galaxy of ecosystems, all planted by the same celestial hand. Let's stretch our imagination even further. What if other planets, Mars, Europa, and Enceladus, already harbor life, but we haven't found it yet because we're looking in the wrong places, or we're not equipped to detect the micro before the macro? What if alien life isn't some green creature with antennas, but something far smaller, far older, and far more intelligent, because it survived not centuries, but eons? And here's the kicker. What if Earth itself has already sent life out into the cosmos? Think about every spacecraft that left Earth without being 100% sterile. Think about satellites, rovers, landers, carrying our microbes, our DNA, our invisible biological fingerprints. Maybe we, too, have unintentionally become cosmic gardeners, spreading Earth-born life to distant moons and asteroids. In our quest to explore the universe, we may already be altering it, seeding life where there was none, just like it may have been seeded here millions of years ago. Now ask yourself, what if we are the result of someone else's experiment, or accident, or gift? The Tiangong bacteria whisper something to us, not in words, but in existence. They say, we're still here, we traveled with you, we adapt. And the more we look at these silent passengers, the more we realize that the boundary between Earth and the universe is thinner than we ever imagined. Life doesn't begin or end with Earth. Earth may just be a chapter, not the prologue, not the finale, of a much older story. A story written across stars, told in molecules, and passed on through evolution without borders. The universe, it seems, doesn't just tolerate life, it encourages it. It shelters it, nurtures it, sends it drifting across the galaxies like cosmic pollen, waiting to bloom wherever it lands. So the question isn't, are we alone? The question is, how long before we meet the others who came from the same cosmic seed, or worse, how long before they realize we're back? As thrilling as this discovery is, it carries with it a shadow, a chilling uncertainty that cuts through the excitement like a scalpel. What if this mutated microbe, discovered aboard the Tiangong space station, isn't just a biological marvel, but a threat we don't yet understand? Science celebrates resilience, but in the microscopic world, resilience can also mean resistance. To antibiotics, to containment, to prediction. Could these space-adapted bacteria, hardened by cosmic radiation and freed from Earth's evolutionary limitations, behave unpredictably once reintroduced into our fragile biosphere? History warns us. Every time life has crossed borders, it wasn't meant to. Chaos has followed. When invasive species were introduced to new continents, rats to islands, rabbits to Australia, or viruses across oceans, the result was often devastation. Now imagine doing that, not across countries, but across planets. Imagine introducing an organism that has evolved under entirely alien conditions back into the ecosystems of Earth, where no predator, no immune system, no safeguard has ever encountered it before. Could it trigger a new chain of infections? Could it outcompete natural Earth bacteria? Could it even remain dormant, undetectable, until climate, contact, or mutation activates it? Scientists don't know, and that's the most dangerous part, because uncertainty when it comes to microbial evolution. ISNT, just a gap in knowledge. It, a potential biosecurity breach with planetary consequences. Now consider this. Most space missions are focused on avoiding forward contamination, protecting other planets from Earth microbes. But this bacteria proves we might now face the threat of backward contamination, where space returns the favor. And this time, what comes back may not be what we sent. What if this is just the first of many space-altered microbes that hitch rides home on capsules, astronaut suits, or cargo? What if we've already brought something back, and we just haven't detected it yet? Our tools were never designed to detect what's never existed on Earth before. These are questions scientists are now scrambling to answer, not just at CNSA, but at NASA, ESA, and even private space companies like SpaceX and Blue Origin. The truth is, Earth's biosphere has always existed in isolation. For billions of years, we've evolved in a biological bubble. Now, that bubble is being poked, cracked, and pierced by human exploration. We're bringing pieces of space home, not just in data or dust, but potentially in living form. And while that opens doors to knowledge, it also opens doors to biological unknowns that we may not be ready for. This changes the conversation around space colonization. It's not just about rockets and rovers anymore. It's about containment, quarantine, ethics. Do we truly have the right to touch other worlds? If we can guarantee that touching them one hurt our own, what if the price of our cosmic curiosity isn't paid in metal or money, but in ecosystems, species, or lives? That's the paradox of discovery. The more we learn, the more we realize how unprepared we are. And so, this mutated microbe, so small, so silent, may be shouting the loudest warning we've ever heard from space. Look closer, tread carefully. You are not alone in this universe, and neither are your consequences. Not all consequences of this discovery are bleak. Extremophiles, organisms that survive extreme environments, have helped scientists develop new antibiotics, enzymes, and medical treatments. The mutated bacteria aboard Tiangong might hold unique biochemical secrets that could lead to breakthroughs in medicine, biotechnology, or even space travel itself. It's a thrilling possibility that the very microbes that challenge our safety could also become tools for incredible scientific advancements. Ultimately, the Tiangong bacteria represent a turning point in humanity's relationship with space. Our quest to explore the cosmos now involves understanding and managing living organisms beyond Earth. Space isn't just a mechanical or physical challenge anymore, it's a biological one. The future of space travel, colonization, and planetary exploration depends on how well we navigate these unseen biological frontiers. This tiny organism could be the key to unlocking a new chapter in human history, or a warning that space holds dangers we've only just begun to comprehend. Now that you've uncovered the hidden story of life surviving in space's harshest conditions, what's your take? Is this an incredible scientific breakthrough that will open doors to new discoveries? Or a warning sign that space exploration carries unseen risks? Drop your thoughts in the comments below. I read every single one and love hearing what you think. If you want more mind-blowing space stories, hit that subscribe button and ring the notification bell so you never miss a cosmic update. The universe is vast, mysterious, and full of surprises. And here at the Daily Scope, we'll be the first to bring you the stories that matter. Thanks for watching, and keep looking up. The truth is out there, and it's evolving.